afternoon, everyone. So, this surprise, we are actually in the virtual campus already, and today we will continue with the story of fluids. And today is 29 Jan 2022, and this is part 3 for fluid story of fluids. And today we'll talk about the measurements, measurement techniques, the units, and the dimensions. Okay. So, as we define fluids as the something that flows. Okay. So, for most important parameter of any fluid is its velocity. Velocity, that means something is moving. How we identify something is moving? With respect to our reference. If something is still, it's not moving. So based on that, we can identify that how fast the other object is moving. So if you stand on the river side and see that the water is flowing through, so you can imagine that that water has some velocity. So you can just put some kind of floating device, some maybe buoy or some boats or something like that, and that will float with the water in the river, and you can identify that how fast it is moving from one point to another. So if it is moving at certain speed, that means it is the distance it is covering with time. So velocity is distance covered in, basically it's kind of unit, so we'll put in a unit time. So that is important. Unit time, and the units having different systems like FPS, CDS, or MKS. So depending on the system you are following, you have to choose the dimensions of this unit differently. So all of this, for time it is all same, second. For the velocity you are measuring with respect to which object. If it is a river, then the flow is much more faster. So maybe we can take hour as a unit time. So how much the distance is covered, that may be measured in a kilometer or meter, and that is over an hour. So depending on what type of fluid you are measuring, sometimes you measure certain fluid inside a pipe, and that may be very slow movement. So if it is very slow movement, better you take the smaller unit time, so you can get a bigger value for the distance. The distance, that unit may be in centimeter or CDS. Let us take FP feet or inch in FPS, centimeter in CDS, and the different units for different parameters. So definitely what we are talking about the velocity. Velocity is definitely something is movement. So without movement, velocity is zero. And as you know, the fluid has the tendency to move. So that's what we got the word fluere from Latin, and that actually defines the primary definition of the fluid. So velocity we can measure in different ways. You can have, just I mentioned in the first point, that we can have floating device, something you can identify very clearly. So that can be start, that can put into the water at certain point, and you can pick it up back at a different point. So how much distance it covered, you can just take out from the first to the last point, and you can count the time how much it took to cover that particular distance. So that is the distance covered in unit time. So if you have the boat, if you have the floating device, some kind of wire that you can put, and you can just find out how much the velocity is. But sometimes the flow in a river or natural stream is very much turbulent. There are a lot of disturbance in the water. There are a lot of circular motion that we generally call the turbulence. So maybe there is a backflow or salinity also there. So due to all of this, sometimes this simple technique that just putting on one device and counting the time that it covering from one point to another, that may not be a good option, because sometimes it cannot come to a certain point that you are targeting. So it can divert from that point, and your reading will go. So that's how we generally use for the measurement of the velocity, that is current meter. So current meter is supposed to have a propeller, and propeller has to have a movement that is forced by the flow. So what is the flow here? That should translate into the circular motion of that propeller. So when it translates into the circular motion, the number of rotations that will give you the velocity. It moves. How it happens? Into the circular motion, that is from the tip. If you take the tip, when you study the propeller blade, the translation you will understand right away. So when it tips into this force, there are always some velocity component, and due to this velocity component, angular velocity component, that actually forcing the propeller into the circular direction, in the radial direction. So the energy it imparted by the flow or the fluid, it helps the propeller to move. So definitely we can relate the flow velocity with the number of rotations. That is a basic mechanism for the current meter, and current meter is used everywhere in the shipping things, in the river, even in the pipes, and we also have now nowadays sonars, that is depth wise it can measure, and also sometimes it helps in velocity. We also can put the UV or light sensitive meters that actually helps in, like if you have some fluid that has to be generally a liquid and it moves through. So if we put any kind of electromagnetic wave, that can be light or that can be sound. So if the fluid is ready to deflect the actual direction of that motion due to its flow, it is useful for measuring the velocity of that particular fluid. So definitely not every electromagnetic wave that you can use for that kind of measurements. So it depends on what type of fluid, what is the environment, because there are air bubbles, there are other liquid maybe mixing with. So you have to choose that what kind of electromagnetic wave that you are trying to use and how much it reflects from its original position. So definitely you have to have a emitter, that source of that electromagnetic wave, and you are supposed to have the catcher or the receiver for that same wave. So whatever it diverts and after what time, that actually can be translated into the velocity, because that we know is supposed to have the same point on the other side, but it has diverted and it is captured after some time. So the distance and the time, if you divide that, that will give you the velocity. So there are many techniques nowadays we are developing to have more effective measurements. Like I have started with the most the crude one, and if you go to more advanced thing, nowadays we also use satellites to measure the ocean currents. So wherever the flow scale is not just a few kilometer per or few meter per second, but maybe 1,000 kilometer over the stretch, you have to find out, and maybe over the days. So for that, just having a visual measurements or maybe a small device is not enough. Definitely, we are talking about the large scale. So that's how, like, if we are talking about the flow in the blood vessels, they are very tiny. That is sometimes a micro scale, and nowadays we are developing nanomaterials. So whenever you are you developing the nanotubes and you are trying to translate some fluid through it or some gases, so definitely we have to talk about that particular fluid and that particular environment to measure it. So maybe the same parameter, but the measurement techniques that you should use should be different depending on the particular parameter or characteristic of that particular fluid and the conduit it has. So depending on that, we can develop many techniques for that kind of measurements. So velocity is very important nowadays. Now if you talk about the climate change, you are talking about the floods, that when it will come, if there is a big flood or big hurricanes is coming, and that will change the ocean level, and when that flood kind of movement that is coming from the shore to the inland, so it takes some time. Same happens if there are some heavy rain happen in the upstream section of the river, so maybe in the mountains, so it will take some time to come to the certain points in the downstream section, in the later section of the river. So if that happens, so it has a particular velocity. So if you know the velocity and if you know that something happened before or some distance before, you have the time that you have the time to react. So that is very important for the disaster management. So they were given by the data from the kind of atmospheric research units or services, like we have India Meteorological Department, we have NASA, we have WMO. So they provide those kind of data, that is something happened, some meteorological event has happened, that may be rain, that may be snowfall, heavy snowfall, or that may be movement of the glaciers. So something happened there and it will translate through the river. So how much time you have before you can evacuate the possibly affecting people from the river side. So that is very important to catch this time. So that is measuring the distance and measuring the characteristics of that fluid. And it is not like when the glaciers melts and whatever the particular movement, that is definitely not moving just how the water moves. They move slow, but they have a huge amount of water. So volume is important. We'll come to the volume and density. So that volume, when it melts and goes through the sections, there are a lot of destructions. So that distance, how much we are there, or we are trying to save people or lives or maybe properties, and how much time we have in hand to react, maybe take the people out to the safe zone. That is very important in this section. So that's why this measuring the velocity is very, very important in the measurement of the fluids. So we'll move on to the next. See the format. So as the velocity, because we are talking about fluids, velocity is kind of translation of mass. So mass, what we see generally, if we weigh it, you can definitely get the mass or the weight of anything, any liquid. But the problem is, it's not solid. So it's supposed to have a container. It's supposed to have container or the conduit of some kind of volume it should cover, and then only you can just, maybe you are thinking of LPG cylinder or maybe oxygen cylinder. Nowadays, like for the COVID situation, the oxygen cylinder is very much valuable for human life, and you have the liquid oxygen inside, and that has poured inside through some measurement with a very high pressure to make it a kind of useful handling. So when you talk about the mass of liquid, that definitely not give much sense, because it directly related to the volume, because it can expand to any section, any volume, and definitely the pressure you apply on this, that because of that pressure it should capture that volume. So nothing is void, so something will be there inside that kind of container. And that's why for fluids, rather than the mass, the density is more important. So density, pressure, these are more important. So when you talk about water, that we generally take the pure water, At 4 degrees centigrade, that's the density is supposed to be 1 gram per centimeter cube. So that is from the uh, CGS system. So it's basically what is density? Dense. It starts from the dense. So how dense the material or the substance is packed. So that means we can go back to the molecular structure. And because of the very weak bonding, the fluid, it may be liquid or it may be gas, so that actually try to move outside and take as much as volume. So depending on the container we have, it should not move much away. So that is your maximum volume it can contain. So definitely for liquid, these structures are more strong. So you can see the water. If you fill up with water, you can see the water level that is more visible. So that water level is or the liquid level is rising till you pour the whole container. So basically it's covering the volume it has. So at normal pressure, at normal atmospheric pressure, so whatever this volume we capture, that in general we take as a how much, what is the density, what is the packing kind of average packing. You cannot ensure that everywhere all this number of molecules that we are putting in that may be same, because there are always some internal motion, some rounded motion that generally happens. So what is the average condition? So average condition is a density, and that average condition we usually using a weighing machine. You just take the whole container on the weighing machine and measure the mass or the weight, and you have this volume of the container. So that is V, and this is mass M. So your density is the average packing of any substance, of any fluid, and we measure it by mass per volume. And we just discussed that in the previous class, that we have the specific, this is density, then we use D, and specific density is basically D, or sometimes we use rho. So specific density is 1 by rho. So sometimes we measure basically which one is more reliable. So based on the reliability, sometimes A by B is a more reliable factor than V by M, and sometimes we want to know that something is known. So if you want to calculate maybe M instead of V, so better we use the specific volume, specific density. So for let us talk about the density. And density, so that is mass in APA, so that is maybe pound volume, so PQ. Or if you use very much traditional English system, so you can replace by pound per gallon. For CGS system, we can have mass, that is gram, and gram we should divide it by the volume, so that is centimeter cube. So sometimes we call it cc, cubic centimeter. So gram per cubic centimeter, that is very kind of generic unit for the volume. Sorry, for the density. For the MKs, that is kg. That is a mass unit, and we can divide it by the volume. So that is we generally use the meter. So meter cube, or is sometimes we use this unit cubic meter, and is very general term for the volume, because sometimes in the hydrology or in kind of hydro power, we store the water in millions of cubics. So there either cubic, that is feet per cubic meter, so that is cubic, and this is cubic. So that's how for different systems we can define the units differently. So that is about the density. Density, definitely we know this relation PV equal to NRT. So we mentioned that this is the universal gas equation. So mostly for liquid, it's remain constant. This does not matter very much. Pressure also mostly because we cannot make further generate more pressure and squeeze the volume. So mostly for PV varies intermittently or interactively for mostly for the gases. So sometimes we increase the pressure, the volume reduces if the temperature is the same, obviously. So if temperature remains same, so this changes the value, the pressure and the volume, because if we are talking about the same substance, same gas, so definitely is molecular mass, number of molecules in a mole mass, that will be remain same, and also universal gas constant, the R, is same for a particular substance. That's all. When you talk about density, that means it's related to these two, molar mass and the velocity. So if these two are some relation, so that means, so what a density you pack to be a particular pressure, that is very important to identify the condition of fluid to keep in a container or use it. Sometimes we are having the bottling plants, some gas bottling plants, LPG bottling plants, or maybe you can talk about the storage of oxygen So for all these points, density, this interplay, the pressure, volume, and the mass, the more you can pack in, that is very easy to transport because you have less number of containers. But always there is a maximum pressure you can create because whenever you have a container, and as you know, the Pascal that we'll definitely discuss more in detail later theory. So all the sides having same equal pressure that is being created by the fluid or the gas. So when this pressure and the resisting force from the walls of those containers that remain same, that means it has a stable condition. But if one is more and another is there, generally outside that is atmospheric pressure that is always there. So atmospheric pressure and this inner strain that should be balanced by the whatever the pressure you are creating by injecting the gas inside. So if that box has to have its original form, so this has to be balanced, and that's why that how much density you can create for a particular substance you should know, because how much you can get, because this volume and mass molar density, that is mass molar molar mass, that is known, and what a volume you can create here. So what is the maximum pressure that you can have, because that has a force balance. So that's why after density we'll talk about the pressure here, and then we'll move on to the temperature. So density, I think you are already understood, that is the average packing of any fluid, that is a fluid density, and we can measure it with mass per unit volume. So basically the pressure, what is pressure? As we know, press, you can push something, you can give a force to a particular body that may be solid or sometimes liquid. So how much force you can apply, and as we count pressure, that is definitely a force per unit area. So what is the unit force over the area, because we are transferring the force to a particular area. So area is important. So next, okay, density we just forgot to mention, that is density we generally measure in terms of the volume. You can take the mass, and you can also use some electromagnetic condition that is giving you the how much moles that is already contained. Mostly we go by the mass for measuring the volume and measuring the weight, and we get the density. So we'll take the detailed classes on measurement of density later on. So now we talk about the pressure. So pressure is very important, mostly for the gases, because as it takes the try to take the entire volume. So when it takes the entire volume, it basically covering the or expanding its own structure. So that's how dilatation is almost maximum or 100%. So what we try to do for the utility, like we try to pack up, the gases in some containers. So that is for the industrial uses. And when we talk about the atmosphere, the open atmosphere, it takes the shape because of two things. One is the gravity, and another is the energy we have. So more the density we have with the more dense gases, that will be definitely close to the surface because we have the factor of the gravity. So every single molecule is under gravity. So more the condition or the position of those molecules near the surface, they will be attracted by the gravity. And what is the lighter thing, that is also the buoyancy will take care. So the lighter things definitely will try to place it away from, because it has more buoyancy and less gravitational force. So we'll come to the force balance later on. So in terms of pressure, that's why we talk about three things: vacuum pressure, or sometimes called negative pressure, absolute pressure, or the normal pressure. So vacuum pressure, that is when a container is have nothing. So what we can do, we can have a container and try to take out all the material, all the gases from inside. So definitely it has to have the strong walls, otherwise what the external atmospheric pressure that will squeeze it, right? So when you just don't blow the balloon, that is already squeezed because of the atmospheric pressure, because so nothing is inside. So when you blow it, when you put air, that is mostly the same density of the outside, and it takes some shape because of that. So internal pressure is more than the external. So that means for vacuum, that is a zero pressure inside. And that, when you talk about the baseline, this is because baseline, what we use basically the normal pressure or the atmospheric pressure. Why we take the atmospheric pressure? Because human beings lives in atmosphere, they don't live in underwater. So atmospheric pressure, what we feel in general, definitely that also varies, because as I told, that density of the atmosphere is not same from the surface to some height, because of the gravitational and buoyancy force. The molecule, the gas molecule, they take the normal position or the balanced position in accordance with its mass or the density. So definitely when we talk about the atmospheric pressure, that is a zero pressure, the reference level. And definitely when the vacuum pressure is below the atmospheric pressure, because there is nothing inside, there is not zero or negative, some value negative. So when in negative value, that's why this vacuum pressure is also called the negative pressure. And normal pressure with the atmospheric pressure. Absolute pressure is when you talk from the zero. Okay, so in general we talk about the pressure. So that pressure basically is measured above the atmospheric pressure. What is the zero atmospheric pressure? surface. So that is the zero level, and from there we really measure the pressure at any point. But when we talk about absolute pressure, it has to start from the zero. Now, what is pressure? I just explained physically that P per unit area, because some force is acting, otherwise the pressure won't change. Okay, so that may be due to internal molecular structure, and you are just having this container and you are just heating up, you are boiling water here and you are heating it. So when you are heating it, you are just imparting more and more external energy, and what will happen that what the molecules they are there, because of this external heat, these bonding again lose out. Brownian motion increases. So all of these, they will have more force that is helping them to try to move out. So definitely the pressure will increase. So this is P. So this force, not always some external force that I am trying to mention, that this force for increasing or decreasing pressure, that can be also in terms of internal, but the energy, because we have the energy balance equal to mc square, so the energy has to come from outside. That won't change unless there is a reaction going on. So nuclear reaction, fusions and all. So if there is an internal reactions going on, then it is a different case. But otherwise, the force would be internal or external, but the energy has to be the external for this things, for changing the pressure. So pressure, how we can measure, because we are talking about the force. We are talking about the forces. So if we can measure the force, and if we identify that what is a particular area is working on, then we simply can calculate by the simple calculation, but the force per unit area, because all the time the force is acting on a surface. So area, the surface area, the active surface area is very important. So pressure, the force start the older one first. I'm trying to follow.